Hey guys, welcome to Deep Dive Coding. Today we solve lead code problem of the day, that is adjacent increasing subarray detection 2. And also the previous day problem was the adjacent subarray detection 1, but the solutions if I show the solutions, that will be the same. So in this video I will explain the most optimal solutions in big of one time and big of n time and big of one space complexity. And now let's try to discuss this problem. The problem is basically says that we have to find two strictly increasing adjacent subarray that have the maximum length of the k. That means what? The If we take the first example of it over here, this is the first example. Okay, so nums will be this one with the first example, and slightly modifications should be there. We are taking this 10, 11 and 12. This modification we have done. So now try to find the strictly increasing subarray. That means the previous number will be lesser than the current number. That means 2, 5, 7, 8, 10 and 11 and 12. This is the strictly increasing subarray. After that 2, 3, 4 would be the strictly increasing, and after that 3, only 3, and after only 1. These are the these are strongly increasing subarray. Strictly increasing subarray. And what we want is, first of all, both the subarray length would be the k, and subarray must be the adjacent of each other. That means if the subarray end over here, first subarray, then next subarray should start over here. So that should be the adjacent, and both subarray must strictly increasing, and we have to find the maximum length of k, like maximum of k. So let's try to discuss these things. That what we want is, if we able to find this way, that first of all we have to find the current subarray increasing length. That means we can found over here that this is the 8 length subarray. After that this is the 3 and 1 1. So if we find these numbers, then we can effectively calculate the answer. That means for the first increasing subarray, 8 would be the length, and after that 3 and 1 and 1. So if we want to take these two are the adjacent subarray, then maximum answers would be the 3. And if we want to take the 3 and 1 is the 2 subarray, then its maximum answer would be 1, because 1 and 3, minimum of 1 and 3, and after that 1 and 1, this is also give the 1 length subarray. But here is the things. In a subarray, the half of the subarray can be considered as one subarray. That means over here is 8 elements, so we can consider first 4 elements is one subarray, and next 4 elements is also one subarray. So in that case the answers would be 4. So that would be the maximum case. So I will show you the first of all 8 by 2 gives you 4. This will be the maximum, as compared to maximum of 8 comma 3. That will not maximum, it will be minimum of 8 comma 3. This will give you 3, and minimum of 3 comma 1. This will give you 1, and minimum of 1 comma 1. This will also give you 1. Apart from that, 3 by 2 is also give you 1, and 1 by 2 is give you 0. So these are the not going to be the answer. So maximum answer would be the 4 over here. Now let's try to write the code as I have discussed over here. So I will take two pointer that will store the length of the strongly increasing subarray. So this will store the current strictly increasing subarray length, and another one is previous increasing. This will store previous strictly increasing subarray length, which is adjacent of each other, which is adjacent. Now I will take this thing current increasing. This will be the one for the first case. Like initially one element always be increasing, so we starting from the I equal to 1 over here, and after that this will be the previous increasing, that will be the 0. And we also take the length to process the current length. Initially it will be 0, and also the maximum length to track the maximum of all the length. So now try to iterate from I equal to 1, I less than nums dot size, and I plus plus. After that, if we found that this element is strictly increasing, that means nums of I is greater than nums of I minus 1, it is greater than the previous element, that means it is strictly increasing, so we increment the counter of current increasing. And otherwise we have to like save this thing, current increment, current increasing is previous increasing is current increasing, and current increasing equal to 1 to process the further. Now at each iterations we have to calculate the length of it, so length will be the maximum of current increasing by 2. That means if we in over here in this case, so in this case the current increasing would be at some time it will be give the 8, so that will be like half of that, it would be the one Sabare, and half next half would be the another Sabare. And another thing is minimum of current increasing and previous increasing. So yeah, this will be the length, and we have to track the maximum length, so we have to take max length equal to max of max length comma length, and at finally we have to return the max length. Now let's try to submit this code for the sample test case. Yeah, it's accepted for the sample test case. Now let's try to submit this code. I will discuss the time complexity of it also. So yeah, it's accepted. So the time complexity would be simple, like we are going to only one iterate over the num size, so it will take big O of n, and apart from that these are the all constant operations. So space complexity, time complexity would be the big of n, and space complexity big of 1, because we are not taking any extra space, so all these are the constant space complexity. Yeah, thank you guys, thank you for watching, stay tuned for the more videos.